Ever wondered how AI models like chatbots get better at answering questions? It's not just about feeding them more data, it's about how they learn from that data. Today, we're diving into a groundbreaking concept called the Distance-Calibrated Reward Margin, or DCRM, which helps AI models focus on the right lessons. Let's break it down. Imagine you're teaching a robot to solve puzzles. You give it two solutions, one excellent, one terrible. The robot needs to learn the difference. But here's the catch. If the two solutions are too different, the robot gets confused. If they're too similar, it doesn't learn much. DCRM is like a compass that balances these extremes. DCRM measures how meaningful the differences are between two responses a model might generate. Think of it as a quality check for training data. It combines two key ideas. One, the reward margin, how much better one response is than another, like rating a puzzle solution as excellent versus poor. Two, the distance between responses, how different they are in words, style, or meaning. By normalizing these values, DCRM tells us if the useful differences, the signal, are strong enough compared to the random noise. A high DCRM means the model gets clear, meaningful feedback, like getting a detailed map instead of a vague hint. To test DCRM, researchers used three models, LIMA2, LIMA32, and Gemma. They created datasets with contrast pairs, responses from the same model or different ones. For example, SSRM, same source, paired responses from the same model. DSRM, different sources, mixed responses from two models. DSFix forced the better response to always come from a specific model. SSRM datasets had the highest DCRM and best performance. Why? Because when responses came from the same source, the differences were meaningful, not noisy. In contrast, DSFix, where the better response was artificially forced, had the lowest DCRM and worst results. It's like trying to teach a robot by always giving it the same answer. It doesn't learn variability. Think of DCRM as a teacher's feedback. If they say this answer is 10x better, but the answers are completely different, the student might get confused. But if the feedback highlights specific actionable improvements, like add a conclusion instead of this is bad, the student learns faster. DCRM does the same for AI, filtering out the noise so models focus on what truly matters. But here's the twist. The team also uncovered a hidden pitfall. When training data includes quirky examples, like responses with random emojis or repetitive phrases, the model might overlearn those quirks instead of the actual content. It's like teaching a kid to solve puzzles by only showing the messy, cluttered examples. This discovery ties back to a broader issue. AI can pick up on spurious cues, like response length or style, instead of the real goal, accuracy or clarity. For instance, a model might favor verbose answers simply because they're longer, not because they're better. The study showed that when training data has clear contrasts between good and bad responses, models improve significantly. But if the data is messy, the model gets confused. To address this, the researchers developed DCRM as a scorecard for AI training. It rewards models that focus on the right features, like clarity or correctness, while ignoring distractions. The higher the DCRM score, the better the model aligns with human preferences. It's like giving a student a report card that measures their focus on the right things, not just their handwriting. Their experiments revealed that tweaks like BON2 or adjusting MSD settings boosted performance, but some changes like training on DSFix datasets actually hurt results. This shows that not all data is created equal, and that small changes can have big impacts. Here's the takeaway: AI isn't just about raw power. It's about how you train it. Whether it's choosing the right data, balancing metrics, or understanding what humans value, this research helps us build smarter, more reliable systems. So next time you chat with an AI, remember, there's a whole science behind those responses. Thanks for watching. If you want to dive deeper into how AI learns, hit subscribe, and let me know in the comments what you'd like to explore next. Stay curious.